So all the videos up until now, I've shown you the following transformations. When given a function, it could be any function. It doesn't have to be sine of x. It could be cosine of x. It could be tan of x. It could be x squared plus 7. It could be any function. So when given any function here, we can apply this transformation here. So let's say for the sake of this video, let's say the function at the moment is sine of x. When you apply this transformation, so your sine of x will look like this. With 360 being here. Now when you apply this transformation, it becomes this. It becomes here 180. So and the equation of this graph here is given by this. Okay, and also when given this function here, you can apply this transformation. So you start off with your graph like this, sine of x here, and when you apply this transformation, everything gets stretched upwards, and then anything here in the negative realm gets dragged downwards. So applying this transformation stretches everything vertically. Okay, and we also looked at what happens when you apply this transformation. So when you apply this transformation, suppose you have sine of x like this. When you apply this transformation, well, negative 90 means you move everything to the right by 90. Okay, so you basically shift everything across. Okay, now that's all nice and neat when the coefficient of x here is 1, but things get complicated when you have this, when you have the coefficient of x being any other number apart from 1. So here let's try and understand this here. In this video we are going to try and understand, or we are trying to visualize this graph inside our mind. Okay, so here when trying to understand this graph here, a lot of people make this mistake. They start out with remember, we are trying to understand this line here. Okay, so a lot of people make this mistake by saying, okay, let's start off with a graph looking like sine of x, and then slowly we will transform it into this equation here. So they would start off by saying, okay, I've got a graph looking like this, and then I'm going to apply this transformation. So this is 360 here, and then applying this transformation, we take it to 180, and then I'm going to shift everything across by 90. So for them to try and visualize this, they would try and picture the sine graph and then slowly transform it into this. But when you come to do that, look at this here. It is actually a mistake. I will try and explain to you why it's a mistake. So hang on. Let's start again. Remember, we are trying to understand this. Okay, and we start off by visualizing this y equals sine of x, and then we would squeeze it inwards by a factor of 2, and then we will shift it. Okay, so let me try and illustrate this. Remember, start off with this, and then squeeze it, and then drag it. Okay, so hang on. So start with sine of x here. Okay, so this is a graph of sine of x. Now first squeeze it. So let me make a mark here. Origin, and this is one period. Okay, so we started off with hang on. Oops, hang on, bear with me. Oops, hang on, bear with me. Okay, hang on. Okay, we started off with sine of x. Okay, and then we're going to apply this transformation, and then we're going to apply this transformation. So the first transformation is to squeeze everything inwards. So wait there. So I'm going to show it to you now. So first transformation is to squeeze everything inwards. So this 360 here will get squeezed to 180. This origin stays the same. Okay, so hang on. Let me attempt to do that. So here the origin will stay the same. So now you can see that point there, which was 360, now is at 180. Okay, so that's the first transformation done. Now the second transformation is to drag everything to the right by 90. Okay, so this is what a lot of people think yeah. So now the so a lot of people when trying to understand this line here, this equation here, a lot of people visualize it like this. So when you visualize it like that, you will ineffectively get this graph. And this graph here is actually wrong. It doesn't represent this equation here. Okay, it doesn't represent this equation here because the true now I'm going to show you a graph, or the true graph of this equation here. So hang on. So this is what a lot of people think. Well, a lot of people think it's this, but it's not. It's actually this. You see, this is a true graph of what we want to understand. Y equals sine of 2x minus 90. This is the true graph of it. If you look at this, if you look at our graph here, this point, it was here, and then it gets dragged across 90. But then if you look at the true graph, it's 90. It's at 0, and then it gets dragged to 45. And why 45? Why not 90? Okay, let's try and understand this here. Hang on, let me start again here. So for you to truly understand this here, okay, you have to first start with, let me move down here. So here, so for you to truly understand this, f of x equals, what was it, sine 2x plus minus 90, sorry, minus 90. Okay, for you to truly understand this, you got to visualize. Okay, I'm going to transform it. I'm going to transform it like this first. So this step here is correct. Sorry, yeah. For you to try and understand this thing here, first visualize this. Sorry, bear with me on this. First visualize this. F of x equals sine of x. So we start out with our sine of x, which is easy to visualize. Okay, and then our next step is to visualize this, f of 2x. Now f of 2x will give me this, will give me this here, sine 2 of x. Now here's a mistake. A lot of remember, our aim is to get to this. A lot of people then think, oh, I'm going to put x minus 90 into this thing here. Okay, well, if you do that, so suppose at the moment you're here, and then you then want to apply f of this thing here, this bubble here. Okay, so a lot of people think you put it into here, but if you do, then look what happens. Sine, and then you've got your 2 here, and then the bubble goes into the x. The bubble here goes into the x here, so it will be this 90. Okay, which will in effect give you this. So remember, well, this you can visualize it as this. So this times this. So in effect, it's like this: sine square bracket 2 bracket x minus 90. And then look what happens. Look what happens. This times this, so that will be sine of 2x, and then this times this, which is minus 180. So you see, what we did earlier up here. Hang on. What we did earlier up here, the equation for this is actually y equals sine. Oops. Y equals sine of sine. Y equals sine 2x minus 180. That's what we've done when we did that. You see, it works nice. It works nicely when the coefficient of x is 90. You can just shift things about. But when there's a 2 in here, it gets complicated. So hang on. Yeah. So if you simply if you put 2x in here, you get to this stage here. Now, if you simply put x minus 90, you would get something that doesn't represent what we want to understand. It's near it, but it's not actually exactly it, because down here we've got 2x here, sine 2x here, which is good, but then we've got this 180. It does not represent 90 here. Okay, so to understand this here, hang on, to understand this here, to understand f of x equals sine 2x minus 90. Okay, to understand it, you have to visualize it like this. Hang on, you have to do this. Just sine. You have to factor out the 2. So somehow let me use, for you to really understand it, you have to do this. I know it's a bit weird, but it's the only way. So factor out the 2. So it's like this: x minus 45. Okay, x minus 45. So when you come to visualize it, let's start out with our sine of x here. Okay, if you apply this transformation to if you apply this transformation 2 of x here, and then you would get sine 2 of x, and then now if you start putting this bubble into there, everything makes sense. So x minus 45. So if you put x, if you put x minus 45, into this x here, you will get this sine 2, and then the bubble here. Remember, we are putting this bubble into the x, so it will be x minus 45. Okay. So here this times this, and then this times this, and when you do that, sine 2 of x minus, now 2 times 45 is 90. So you see this here does give a good representation of what we are trying to find, what we trying to understand. Okay, so for you to truly understand this this function here, you've got to factorize out the 2, basically get it so that x has a coefficient of 1. When x has a coefficient of 1, then you can simply put whatever you want into here. You can put x minus 45 into that x, and then it will make sense. So when you try and understand something like this, I know it's strange, but you've got to take the 2 out as a factor. So that you can get x on its own. You see this x minus 45 here. If you go back to the original proper graph, the proper graph for what we're trying to understand, you can see that is a shift of 45. And if you look at the wrong way of doing it, you see our wrong way here, we shifted across by 90. But we've got to do it 45 basically. So remember, when you are trying to understand this here, try and get it somehow so that you have x minus so that you have the coefficient here as being 1. So in this case, it's like this. So if you get given something like this, let's say 3 x minus 90 here, for you to understand this here, somehow try to get it so that the coefficient of x is 1. So here you would do it like this, sine, and then take out the 3 as a factor, and then x, and then in this case 90 over 3. So it would be this. So when you come to multiply this here, it will truly give you this. So remember, try and get it so that the coefficient of x is 1. So then you can simply drag it along easily, rather than, well, I know it sounds weird, but it has to be a 1 here. Okay?